Okay, here we go. Now we're done with single phase and we're going to begin three phase shop jobs. And so 2201 talks about just starting and stopping a three phase motor. And we're going to have some different considerations that we are going to have to add in here. If you remember from manual motor controls, we have an overload in our motor starter. So we have an additional input here. And of course, we are going to be operating a three-phase motor. And we're going to be controlling that with a motor starter and not a control relay. And then we're also going to have an indication on the overload that's going to go to our yellow light. Again, our red and green lights are going to be hard-coded, hardwired. So let's go and look at the panel and a program. I'm going to jump all the way back to shop job 901 because this one closely resembles our three-phase, and we're going to start to modify this. So first thing I'm going to do is save this as 2201. Okay, and then here we're just going to change this to, okay, all right. So E-stop, stop, start, that's all the same. Now here, this output 3 is going to be rewired. You can see over here, we're going to call it MS1 because that's our motor starter. And so we need to rename or re-symbolize that from CR1 because we're no longer wired to CR1 and put it to MS1 here. Okay, so it's still the same address. So all we have to do is just change this to MS1. And this is a motor starter. Okay. And then this would be MS1 stat. And let's see what I actually called it here. For my status, yeah, motor status. Okay, MS1 stat. All right, so now we have the overload that we are have to be concerned with. Now, of course, we still want to make sure that we were the initiating factor in starting the motor. So that's why we have this address here. That's a copy of that address in our output of our rung. But we need to add in the overload. Now, if you remember from manual motor control, we actually would put the normally closed looking, or for manual motor controls, it would literally be a normally closed set of contacts to the right of the coil on our drawings. And that's what we do out in the field, mostly because those two are so tightly coupled to one another. It made sense. Well, inside the PLC software, we cannot have a test instruction after a set instruction. Okay, remember this, we kind of generically call this an output instruction, but what it's doing is setting a value to that address. And then this instruction is testing the value of an address. Okay, we can't have it over there. So what we need to do is put it over here with our disablers. Okay, so this is another place where we're actually going to follow the convention that we broke in manual motor controls. We're actually going to follow it here. So all of our disablers will be over here, and I'm going to add it after my stop. And I'm going to want an examine if open. So if our normally open overload contacts are open, that means we're good. If they're closed, that means that we're in an overload condition. So if I tell you that the motor overload contacts are 97 and 98, and if we look at the sheet here, I tell you that the overload contacts are 97 and 98, and they come in at address 0.0/9. And then we can also look down here and know that 97 and 98, you can see it right here, are the normally open set of contacts. So that's why we want to use an examine if open. So we have our examine if open, and now we know it's I:0.0/9, which I don't have symbolized. And let's check to see what I have that on the sheet, this sheet here. I call them MS1 underscore OL. Okay, so these are just going to be motor overload contacts. Well, let's call it status, just so we're consistent. And this will be MS1 OL. Okay. So what this is saying is if our overload contacts are open and our stop is closed and our e-stop is closed, and once we close the start button, we're going to energize our output, and we are going to have a holding circuit then that will keep our motor running, and we won't have to hold down our start button. Okay. So now we have something else that we need to indicate. Of course, our red and green lights are hardwired. That's what the asterisk here means. It denotes a device external to the PLC, so we don't have to worry about it inside the PLC. But I do have another output device here, and it's these motor overload light to indicate that we are in an overload condition. So I need to add a rung down here. And this is going to be for our yellow light. And if we come over here and double check our yellow light address to make sure, it is this O0.0/0. That is our in this case, going to be our overload condition. So O:0.0/0. And this is going to be overload status or indication, and this is just going to be spelled out overload. Okay. All right, so what actually tells us that we're in overload? If we're open, that means it's good. So if it's not open or closed, that means it's bad, and we want this to show us the bad condition. So we're going to do an examine of closed here. Okay, so if the overload closes, that's bad. So if it closes, we're going to turn on that overload light. Okay, and then when it opens back up again, when we reset it, it will extinguish the light. Okay, so that is our shop job 2201. Okay, let's go ahead and download. And so now we can see that our e-stop has logical continuity, our stop has logical continuity, and our overload is in a non-overload condition, or in other words, those contacts are open. So if I press the start button, I should energize my, this is actually forward is on the right and reverse is on the left in this particular panel. So this will energize that, and it'll be difficult to see, but that should move there. And then that will close my MS1 status contacts, and since we've already driven that output, we'll have a holding circuit here. And once we do that, then we'll test our overload. So I'm going to go ahead and hit start. Okay, and see to just to the right of the motor starter, the relay that's actually energizing these lights come into play, and I'm going to go ahead and hit stop. So there's my start-stop station. Okay, I'm going to go ahead and hit start, and then I am going to simulate an overload. And you notice that when I held the button down, the overload contacts were closed, so my yellow light was on, and when they closed, this no longer had logical continuity, and it stopped our holding circuit. So what this is doing is breaking that holding circuit. If we did not have that in there, as soon as we reset our overload, we would actually go back to a running status, and we want to expressly have the operator need to press start to begin another running sequence. So that is Shop Job 2201. I hope that helps, and we'll see you in the next video.